Today, on part 7 of fixing 6 Pro Control lasers. Today we're going to be putting in new blue laser diodes in this laser head. Laser diodes can fail due to a couple of reasons. Normally it's catastrophic optical damage, or it's just in general junction degradation, which these laser diodes have in them. So basically what happens is the semiconductor material in there will start to break down between the PN junction of the laser diode, but it won't damage the little mirrors inside of the laser diode junction. So the light gets dimmer and dimmer and dimmer, much like how an LED will get dimmer and dimmer, especially if you overdrive it. And these blue laser diodes in here are the good old M140 A-type, the 1.2 watt laser diodes. Probably overdriven a little bit. So we're going to replace them with the M140 M types, which are the 2 watt capable version, about 1.8 watt capable version. We're not going to be running them that brightly. And since this is a little bit of a longer segment where I'm just going to be doing a lot of the work on the fine optical parts, we'll get a little bit into how I got into lighting. So, which basically all starts when I was about 3 years old. So I have an aunt, and my aunt was an electrician, so she would always have these broken flashlights, and of course that's what you give to a kid who's 3 years old. Broken flashlights. I was born in the 80s. Times were different. We didn't have these new digital distractions available to everyone. Smart toys had a whole different meaning. But yeah, so I got all these broken flashlights, and by the age of 4 I realized how to put new bulbs in and stuff like that, and get new bulbs every once in a while when she'd bring over a flashlight, and I ended up having this little desk drawer just full of broken flashlights and stuff like that. A lot of fun. I guarantee you, if you give a 4-year-old a couple of batteries and a broken flashlight, they will figure out how to get that working. We humans are hardwired for figuring stuff out. That's what we do best. So yeah, broken flashlights. I had a lot of fun with that for a while, and I was about 5, 6 years old when I realized I could pull the lights out of Christmas trees. And as a result of this, we had very dark Christmases. It was many years that I would just go and pull the light bulbs out and pull the 9 volts out of the smoke detectors and figure out how to wire them up and put them in like little cars and Lego creations and stuff. I used the plastic little hinges to make my own switches with the Lego creations and stuff. Pulleys were a lot of fun. Give them a couple wheels and rubber bands and stuff, and they'll have things moving in no time. Humans are smart creatures. Don't underestimate the child's mind. Humans are smart creatures. Alright, so inside of the laser head here, we got the 2 blues, and they're in series. So we got the positive coming in here to the anode, that M140 here, coming out of that cathode, going into the anode here, and then back out of the cathode. And so we got the 2 knife edge arrangements here, a little fickle to get into. We're going to carefully remove those out, and then we're going to remove this whole laser assembly out. It's mounted on a 60mm square thermoelectric cooler, which we're going to have to be careful. Place it down with even pressure when we reassemble the laser head. But yeah, first bit, those guys. So yeah, very dark Christmases. And this went on for years, and then LEDs came out. I'll tell you, it was the only reason I did house chores, so I could get LED money. Go to Radio Shack, see what they have for LEDs, get some new LEDs, play with them. all the other kids had some weird stuff. Normal toys. I guess I was the one with the weird stuff. The impression, or the empowerment you have, and the impression you have on other people your age, especially when you're in kindergarten, first grade, second grade, that you can make things light up and they can't. Oh, that's an amazing feeling. It's like you have this magical ability that other kids don't. You can bring things to life in a way that they can't. So, yeah, that was fun. Made a lot of things with that. One thing I didn't like about the Christmas tree lights is the darn little copper wires on the bottom broke off all the time. But then LEDs came around. Those were great. They only came in a couple of different colors, though. Didn't have the blues up until, I think, 1994. By the time I was 7, 8 years old, around there, the blue LEDs came out. And they were really expensive. Nope, I'm using a magnetic screwdriver. For sure. And I'd always get different LEDs and stuff like that. They'd have these multi-packs of the early red and green and orange LEDs, but no blues. One of my favorite things to do was to get the bicolor red and green LEDs and make little stoplights and stuff like that in the Lego cities that I made. They were kind of like ghost towns. You know, not many people were in them. So the 5mm LEDs can be pressed into Lego blocks just naturally, because the hole in the Lego blocks are also 5mm. This is something that I learned really quick, and when I was about 9 to 10, I went and I wrote Lego and sent them one of my little LED things, and they said, no, we do not take ideas from other people, and that was that. Kind of sad, because they ended up putting LEDs in Legos anyway later on. Just poop on that. It's a great idea, how could you not? It's not the kind of thing you want to be reading when you were a 9-year-old Lego fan. There you go. Alright, now with those two knife edge arrangement pieces extracted, we can pull the whole optical assembly out of the laser head. Those are dirty. Here's what they look like. Focus. Focus. Yeah, you can see all the smudging on there. Dichroics, when they're hit with that kind of laser light, can break down a little bit. But usually it's just dirt and buildup from that laser beam, kind of ablating things off it and ablating, carrying the moisture, whatever's in there, and a little oxidizing. Yeah, definitely oxidizing something in there, just a little bit. Maybe it's the glue, but it's not present on the reds. So it's probably more prevalent on blue optics, and you'll see that they need cleaning more often. However, totally not the reason of why we're getting a yellowy laser beam out of here. No amount of dirty optics will do that. Well, they will, but not like that. Alright. Yeah. Now the fun part is being careful with these bolts. And go around, loosen them up evenly. As I said, there is that Peltier junction underneath. Yeah, we'll leave these in there. They can just sit. That's what I did on the other one. We'll pull out some of these, like by the optics here. Definitely pull those out. Yeah, we have to. Yep, little electrical isolators in there. Cool. So LEDs and everything. Lots of LEDs and the Lego stuff, Lego City stoplights. As I said, not many people in my Lego cities. Then I got into the spaceships. When the blue LEDs hit the market, that was great. Because then you could use the blue LEDs to light up the different fluorescent pieces. And that made for some great spaceship Lego crafts. Especially with the fiber optics. Rebuilt lots of the Lego fiber optic stuff over the years. Lost them all. But that's what kids do. Yeah, we'll leave that one there too. There's actually two of these lasers that needed a replacement blues. You might be thinking how this is going to go. This is fairly routine. I already did the other one. Didn't even need to reset that driver. That was nice, perfect white balance off the bat. Really lucky about that. So it makes for a really straightforward repair on these. The more complicated one is going to be the Lightspace unit, because that's the one that's going to require me to isolate the little diode blocks electrically, because we can't have them together. The laser diodes are going to need to be in series, and they're not case isolated. Shame on you. So now we very carefully extract that. Right. And then on the bottom, there's a couple of screws that I have to remove very carefully. That heatsink out of the way. That TEC out of the way. Come on. Oh, razor blade. That's what I need. Talk about being between a rock and a hard place. There was one around. We're gonna break that seal. Just like that. Alright, and then 3 screws underneath there to remove the blue assembly. We're not using that one. Let's have to go fish. Oh. They have smaller ones on there. Oh, the other one used bigger ones. Well, that's not very consistent. Very well. We shall use this smaller one. So when doing the laser swaps, there's just basically a couple of things you gotta keep in mind. One, obviously, color. Second, obviously, being current consumption. And thirdly, divergent factor. And the M140M Type 2s, they're a little wiser, they're wiser too. They won't blow up as quick, they'll last longer. But they're a little wider of a beam, and it's not going to be such a big deal. The anamorphic prism pair on the optical table will take care of a lot of that problem. And those can just fall out. Here we go. And that's the jewel you want. Oh, Oh, right. Time to get those laser diodes out. And there's the old valve module, which we're going to be just rebuilding. For the meantime, we don't want this to get dusty at all, so drop it back into the case very carefully, but not perfectly. And we'll come back to that, but I want to keep this as closed as I can. There you go. That'll do. Right. So, here we have the laser diodes. And you can see that there's two in there. They look like, oh, they're 9mm laser diodes, aren't they? These aren't the M140s. Wow. That's a bit of a shocker in there. Well, that's not very helpful at all, is it? Well, as you see, I found mounts for the 5.6mm laser diodes, and they're ready to be put into the case. And by I found mounts, I mean I had to take them out of the aluminum heatsink that they were originally part of. Hence the very handmade look of them. So, now that the laser diodes are mounted, we can start with the wiring of the laser diodes, and the first thing to do is to run a small wire jumper between both laser diodes here. So let's get that going. Small wire time. The soldering iron cord is forever a bane in my existence. Oh yeah, so where was I? The story. So, ever since LEDs came out, and I realized that I could build things that other people didn't have, it kind of was my goal. Until one day when I saw my first laser, which was incredible, let me tell you. So, I was at church, and something that I was kind of consigned to do, being in that kind of family growing up. And we had a choir of male singers that came in to perform, and they were from one of the technical colleges. And what ended up happening is one of them had a laser pointer, a little red one, and it was unlike any other light that I've ever seen in my life. Just the fact that light could be a little sharp point that you could shine far away just instantly piqued my interest. And I was like, what was that? And of course, like most young children, kind of followed it around for a while, but then I got into a really interesting conversation. Thus being the 11-year-old I was, I had to ask every question. What was it called? Where did it come from? How much was it? If I could get one? All the questions. And this led to a couple of evenings of, Daddy, 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 can you buy me a laser pointer? No. You're going to take it apart. I won't take it apart. You're going to take it apart. Well, that lasted about a week, and then I took it apart. Now, when you're used to dealing with light bulbs and LEDs and stuff like that, things make a little bit more sense. But when you open up a laser diode, or sorry, a laser pointer as a kid, and you find nothing except this little crystal inside, it kind of gets a little weird. Your understanding starts to change a little bit. And they go, how does light come from this little crystal? I remember having the laser diode folded up in a little pink post-it note. And if you were very careful, you could stick the two AA batteries on the laser diode crystal, and sure enough, it would light up. Really cool. And then I got a green laser pointer, of course the same deal. And the internet's pop modding got to me. It's a bad thing. Decided I was going to pop mod my first green laser pointer. It didn't last very long. I think it lasted all of about 3 seconds, and then poof, gone. So I don't recommend pop modding, but that was also a very interesting trek, because it was the first time I've ever seen the light change colors from the infrared to a different color, and no idea that light could be transformed like that. Give me your parts. Give me your very delicate parts. And it actually took many years for me to figure out that light could indeed transform. Because I was looking for green laser diodes to replace the laser diode with. They didn't have any. No green laser diodes. It's like, okay, well, how in the heck does green laser pointers exist? Yeah, that got confusing. Of course, this stuff wasn't on the internet as much in the late 90s, early 2000s as much. Yeah, you see a little bit more of the little bits of oxidation and beam traveling damage on those anamorphic prism pairs too. Delicious. More damage. Yeah. And pretty much all through high school, continue with building the lasers and little things that lit up. This is a hobby. I remember my first year of 6th grade, going in with a little CD-ROM, burning sled, and oh yeah, here's the laser, and this is how it does, and my teacher had no idea what I was talking about, but they gave it a good effort in trying. By the time I went into 6th grade, even though I was going into a special school, they figured that my reading percentile was in the 99% percentile, and they figured that my science skill was that of a sophomore in college. Talk about skipping leg day, because my brain is not exactly one of those even playing field brains by any means. Kind of like that wizard that can only run 2 miles an hour. Very uneven mental skill sets. That's okay. I get by with it. Yeah. Actually, in high school, the fact that I had different color laser pointers, I had the green one. And one day at one of the assemblies in the gymnasium, somebody was pointing around a laser pointer at the teachers. Of course, I was the one that was accused right away, because I was the kid with laser pointers all the time. Except the odd part is that, yes, everybody else had red laser pointers. I had a green one. And well, I wasn't supposed to have a laser in school, but given the fact that the dot shined at the teachers was a red one, also kind of cleared my name with that. Oh, alright. How to get everything all lightly press down on that the Peltier junction. Yeah, looks good. Cool. Now to start screwing things in. Helps to have the right screwdriver, doesn't it? Many years of taking things apart with the improper tools, putting things together with the improper tools. It's kind of been an ongoing trait as I work to get that shop and keep up with the mental skills, so to speak. Got a lot going on in my brain. I just can't execute everything I want to. One day. It'll happen. What is stopping you from going into your home? I got one of the wrong screws. Go figure. Ah, it's an outside screw. Get back down there. Threads again. Much more with threading. And of course, putting this back together, you're going to want to make sure to apply that same even pressure along the base, simply because you got that ceramic thermoelectric cooler on the bottom. And you don't want to crack that ceramic. Kind of makes for a useless thermoelectric cooler. Right. Now to electrically connect the darn thing up. Did we get a blue laser light out? Which we should. Yummy, delicious blue laser light. And then, of course, gotta focus. And reset all of the optics. Which is a fun trek into Tediumville. Ah, gonna need more powder. Ooh. Come on, you blasted little wire. There you go. Cooperation is not suggested. It's mandatory. Mandatory cooperation. So yeah, basically what I did for a while, just because I was bored, is all I did was make these crazy little light boxes. One of them was already up on Facebook, probably one of the last ones that I really went all gung-ho with and made a crazy, extravagant piece of technology with all the lasers and stuff in it. But yeah, that's basically what I did for years, was to make a little random light-up stuff that nobody else had with lasers and LEDs. And did that for many years, just because I could. It helps hone the skills. If you want to get into lighting and stuff like that, just throw random stuff together. Go ahead, do it. It's fun. It's a lot of fun. You can make little doodads and stuff that blink and buzz and stuff. Oh, a little more. You can do it. You can do it. You can do it. Beautiful. Beautiful. Alright, let's give that an electrical test, and we'll see how it looks. And that is, of course, I have to go grab the ILDA cables and all those connections and stuff, get it all set up. We'll come back to that when it's done. Alright, at this point I've done all of the internal optical alignments for the laser head itself. I figured do that off camera because it's going to be a little easier for me without that in the way, and kind of need to get both hands in there and move around the little things, but I'm going to get into those in the Lightspace unit. Pretty much the same optical mount setups. However, a little bit less fragile, fickle of a laser had to work on. So we're still going to learn about all those adjustments, just not with this laser. Anyway, the next step, before I burn another hole in my shirt, is just to set this here, so that way I can kind of work with it a little safer without that direct beam coming at me all the way. It's quite a lot of power. It's about 3 watts of blue laser light coming out of there, so it's a little bit stingy. In the meantime, let's take a look at one of these, because it fits with the story. Now, this is a high school time, and I'd not really quite figured out a lot about laser diodes themselves, but I have been getting into the optical sleds, as mentioned before. Now, a lot of people will show these things, and they'll make the comments about prisms. Now, I've never seen a prism in one of these optical sleds, so eventually I want to go through and just kind of do a video on the parts inside of these little optical sleds from the media readers, such as the DVD, CD, and Blu-ray, but no prisms. In fact, a lot of these pieces do contain glass that looks like prisms, mostly either the beam splitting cube right here, or these little guys, not prisms. They're just dichroic reflectors, and you'll see dichroic reflectors used quite commonly in high-end laser systems, high-powered laser systems, because dichroics don't degrade the same way as mirrors do. So they just kind of last a little bit longer and provide a little bit more reliability with the optical device. So let's get some of these little screws screwed in. Let's see where the all the mounts go. And we'll be able to line up all the primary colors, the red, green, and blue, in this laser, and get that composite beam, nice white composite beam. This is all pretty simple as well. The kinematic mounts are pretty easy to work with. At this point, probably can close up the laser head too, and wipe off some of that heatsink compound on the side. Alright, let's close her up. Yeah, I'll screw that down in a little bit, but we're just going to have the top on for the time being. So let's get these optical mounts, the dichroic mounts, put in. See how our beams look together. Everybody can play nice. Be part of the bigger picture. So, I was learning about the burning CD players, burning CD drives, and at that point I was really kind of confused, because another part had popped up. You can see in the old CD, DVD, ROM readers, they didn't have one particular part. I can actually show you that part in this sled. Alright, so that one particular part right here is another photodiode up in that section right there. And for the longest time, I actually thought that that was the burning laser. Of course, you put power into that, and that piece will get pretty warm. So I figured, hey, if the piece gets warm, it's got to be the laser that burns things, right? Well, no, I was wrong. So it wasn't until the late years in high school that I actually figured out that, oh, hey, no, the regular diode is that thing that does the burnings and stuff. Pretty pivotal moment in my understanding. And of course, there was a while where I just didn't understand anything as far as the current control of laser diodes and stuff like that. Yeah. And make sure I can move this optical assembly back and forth a little bit so I can line up the beams more precisely. There is a adjustment this way, which is why these are cut out, because you have to line up all the beams on the plate side So for example, you'd line up the red coming through the plate with the image of the blue on the plate, that dichroic glass. So there is that that adjustment to think about. Come on, move, you heathen. Yeah, all the screws are loose, whatever. We'll move it. It can be moved. Let's get some more colors of laser in here. Alright. It's looking more color balanced already. So yeah, it's kind of how I started off, and you can see some of my earlier videos where I just used a variable potentiometer to control the amount of voltage going to a laser diode. Now at that point, I had no idea about current regulating laser diodes at all, so I just kind of continuously cooked laser diodes. Now let's see what we get for the output. So there's our beams right there, still not in line, still a little yellowy because we don't have the optimal reflection of the blue off the galvo mirrors, but getting there. The camera kind of blurs the colors together a little bit more than they appear to me, but that's what you expect from an iPhone 4. Alright, well, let's see if we can get those all nice and lined up. So yeah. Lots of learning just on how lasers work themselves, and then learning about current regulating. And once you know about current regulating, laser diodes become such an easy thing to work with. They really do, because all you have to do is worry about one thing, and that one thing is current. Pretty much all you have to worry about. Current. What's the current requirement of the laser diode? Figure that out, you're good. Alright, yeah, that's going to need to be moved back just a little bit. Oh, nice. Nice. I like that. Those look all lined up. Cool. Alrighty. Kiddos, see what we get. We're going to have to adjust the red a little bit, I think. Bring it down. Yeah. And the red being the biggest beam as per always, because that's how it goes. Which kind of mix we can get in there. That's looking like a nice white beam. I'll turn up the power a little bit. Oh yeah. Looking nice. So, not quite so yellowy anymore. It's a nice pretty nice white coming out of that laser beam. Yeah, this is all laser light right there. Kind of hard to tell. Come on, you can do it. You can't do it. That's okay. Yeah, that's a nice nice white coming out of there. That'll do. Alright, I'm gonna get this laser all wrapped up, and we can talk about how I got into the show laser aspect of things, because that's where my story gets a little bit more interesting. I guarantee it. Alright, now on to the Lightspace unit, which has bad red output. So, there's going to be two faults of this. It's either going to be, number one being a driver issue and not putting out enough current, when the laser driver gets the ILD input signal, or it could be what usually happens, and that is catastrophic optical damage. So, what is catastrophic optical damage? It is what happens when you put too much current in a laser diode for too long, and it'll actually destroy the mirrors inside of the laser diode junction, and it just burns everything out. This can cause the laser diode to become much more conductive, and it usually ends up being a little bit more conductive. You'll notice this, the laser diode gets warmer than it should when operating properly quicker. So that's the higher conductivity taking more current. Delicious. So we're going to do the test to determine whether it's the laser driver or the laser diode. And for that, what I'm going to do is I'm going to hook my multimeter up in series with the two laser diodes, and given the output power, I should be seeing anywhere from 0.3 to 0.6 amps. Probably going to be about the 0.4 to 0.5 amp range, given that each one of those laser diodes, let's say, are 340. I'm assuming that's 340 milliwatts per each diode. Yeah, giving us about 0.4 amps we should be seeing on there. So what I'm going to do now is I'm going to take off the cover of the laser, and I'm going to power up the laser unit then with this in series, and that'll give us the current readout once we set it in the right areas. So that's what we're going to do. I've already removed all the screws on the top and the screws holding down the laser assembly, since we're most likely going to have to be putting in new laser diodes. Wow, that's a quite warm lid. Huh, everything inside is frosty. Okay, that lid couples with the base, and the thermoelectric cooler must be under there. Boy. Alright, well, moving on. You don't really need to run your laser diodes at 10 degrees, you know? It's kind of overkill. But I didn't design it. Alright, so where was I in my little story as I fish these little wires out? At that point in life, I was pretty much still building little goofy gizmos and fresh out of high school. Pretty much retarded on how to actually hook up and control lasers. I knew about the burning lasers, but I really didn't have any idea about the current regulation stuff. So as I said, pretty much just blowing up laser diodes. And all the confusion with the dummy load stuff. I've never found more useless information online than laser dummy loads, laser diode dummy loads. Yeah, pretty much as long as you know about the current and how to current set laser diodes, you're good. Don't need a dummy load. I don't ever intend on using one of those myself. Why have a dummy load when you have a smarty meter? Anyway, yeah. So, what did I do? When I got out of high school, got a normal day job because I thought I'd never be able to afford to work on lasers like this. And then built a gaming computer and spent the next 2 years of my life playing video games, which I'll tell you is nowhere near as fun as working on this stuff. I like a challenge. So yeah, I mean, I continued to build little goofy light up stuff, but I really did just get sucked into gaming, mostly besides the gaming stuff. The sucker for the Elder Scrolls series, especially Morrowind and Oblivion. Good games. Games to lose your life to, especially with the modding community. But it was, as I said, it was different. Didn't really have all the information on the internet that you do now, and I was kind of lost and confused for many years. The addition of the mysteries behind the green laser and how those worked also kind of left me in the dust for a while. And until I realized, or not realized, but learned about the DPSS laser technologies, where different crystals could actually change the color of light, which was a monumental breakthrough. But it wasn't until a couple of years later that the laser pointer market dropped to the point where you could pretty much, horrible solder connection right there. But it took a while for the laser pointer market to drop where you could literally buy green laser pointers for under $100. My first green laser pointer was $100, which is about 20 times what you pay for a green laser pointer these days. So, wonderful time to be a laser enthusiast. One of the best times to be a laser enthusiast. But anyway, at that point, what I started to do when the laser market kind of went boom with the cheap green laser pointers is I would contact. What the devil? Are you just disagreeing with me? It's the story. It really is. So there's a boom of laser pointers on the market, and what I would do is I would contact different eBay sellers and see if they had broken laser pointers. Get it here. Hey, look, finally. Stupid oxide. Oh yeah, this has some of it too on there, doesn't it? But I don't wanna. Yeah. So what I would do is contact different laser pointer sellers and see if they had defective laser pointers. And oh yeah, they totally did. Tons of defective green laser pointers everywhere. I would order them by the box loads. Basically get 30 to 40 of them for $20. So 50 cents a laser pointer. And most often the problem was that the crystals weren't as efficient, and people didn't get the high current batteries, the high current alkaline batteries. So oftentimes you would get a perfectly fine green laser pointer that somebody just didn't put batteries suited for the current. They'd ship it back and go, well, the laser doesn't work. Alright. With the multimeter there, we're going to put it in current. We're going to see what we get when we raise the LDA signal input. Current DC. Over there and watch with me. Yeah, maybe you can see that. So yeah, that's kind of what I did. Is I just ordered both lots of broken green laser pointers, and that stocked up parts for me to learn about the DPSS laser technology. And I definitely say if this is something that you want to get into, looking for the green lasers, broken green laser pointers from sellers online is a good way to go. Alright, well that's our red signal, and getting a little bit of red. Let's see what we go up to on the meter. 0.9, 1, 0.13, all the way up. 0.13 isn't enough power to power anything. Well, that's dismal. Right. So, is it a driver issue? Hard to tell. I don't like the fact that it's only see, that just doesn't seem to be enough current for those laser diodes. Should have some wires here. Aww, I think it's a laser driver issue. I would expect to see a lot more voltage on there. Not more voltage, but more current. Yeah, 0.3 doesn't seem to be enough. Not enough for me. At least be seeing 0.3 to 0.4. Well, interesting. Any broken connections? That's bizarre. And I'm starting to suspect, wow, that really does get warm, doesn't it? Wow. Why are you running that thermoelectric cooler that hard? Oh yeah, you can already start to see some condensation on the lasers. I don't like that. Maybe this thermal sensor is broken. Wow. Right. Well, this is going to be complicated, as life always usually gets. So, yeah. There's something goofy with that. Let's take that apart and see what the laser assembly looks like on the other side. I'm surprised it's getting as warm as it is and as cold as it is. I do think there is a problem with that little thermal sensor in there underneath. Very well. Pick up the now very hot laser module. Well, that's not pretty. What is this? Holy frig. Well, that's all unexpected. Well, let's hope it's a driver issue, because it sure seems like it. But I don't want to take the laser driver out. As you see, I've taken out the laser head completely from the Lightspace unit. And over here I have the ILDA connections, and I'm using the green signal alone to control the red, because I know that that cable is absolutely good, just to make sure that the proper signal voltage level is going from the ILDA here. And then over here I have a separate global power supply to run everything. Joy. This is the interesting point in the video where I either figure out how to resolve this issue easily, or I kind of put it in the box and come back to it on another day with some better laser diodes, drivers, and whatever. The part that's going to make this extremely difficult to work on is the fact that all of these are sealed with silicone, so can't really do much about that. Very hard to get in there, get all that material out, and undo the screws. They are thoroughly potted. Given the 340 and seeing the current from the driver being so low, I really do have the sneaking suspicion that each one of those laser diodes just might be only 170 milliwatts a piece, which would explain a low current for the most part. So, as for any interesting point in the video, let's continue on with the story, how I got into the club laser scene. This was the time where the MySpace days were very popular, and anybody could meet anyone. And I met someone, which happened to be an exotic dancer who lived in Texas that was originally from my local area. And her and I got to talking, and it's actually a really cool person that I got interested in talking with, and later on she ended up moving back. Yeah. Her and I got into a relationship for about a year, and that whole relationship was somebody who had really next to no social life, being me, being paired up to someone with an extravagant social life, being her,
And one of the things that she loved to do was to tour me around the nightclub scene with some of her DJ friends. And of course, this would result in her telling me to show her friends some of the little light up gizmos because they were DJs. And she always gave me the whole baby, you're so good with lights, you should light up some of my friends' like events and stuff like that. Well, at that point, laser and lighting equipment, mostly laser equipment, because of the lack of different color laser diodes, the Blu-ray purples were just coming out on the market, and there were slim to no easily accessible blue laser diodes. Not until the Casio projectors came along. The laser diode based projectors, those were really popular with the laser community once they released, but the cheapest source of laser diodes. Anyway, after about a year of hearing this stuff and her telling me that I should get into doing lighting for her friends, I did. But only a little spitefully so, since we broke up and I just wanted to get in her scene and just become a little bit more popular than she was. That was a success, as I spent the next year to 2 years kind of bringing goofy little LED and very simple just laser setups to the places where her friends were performing. And that was a lot of fun, kind of showing up with lights and stuff like that. And yeah. And this coincided with the just explosion of different laser technologies out on the market, as far as the blue and violet laser diodes were considered. And I remember seeing my first laser scanner at a show called Global. And when I saw lasers make images, well, my imagination just exploded. And I really wanted to mess with show lasers, like majorly so. I actually ended up buying one of the very first show lasers that I saw, but a couple years down the line. Alright, so here's what I'm going to do at this point. I'm just going to make sure the laser diodes themselves are good. I have my little adjustable power supply here, and I am going to be putting in about 4.5 volts, because the laser diodes are in series. Take about 2.4 volts a piece to 2.2 volts, and I want to see if they laze at all. If they do not laze, it's not a driver problem. If they do laze, it's a driver problem. So yeah, let's see how these things hold up on an adjustable power supply. See if we get any red laser light out of here. I'm assuming that green is negative and the red is positive. Yeah. Alright, now we get to be mindful of everything, because here's where we could possibly cook perfectly good laser diodes. Don't want to do that. Will you be laser problem or driver problem? At this point, I'm sincerely hoping that it's a driver problem. But yeah, no, I got into doing the laser light shows and stuff like that, and getting broken laser equipment and cheap laser equipment, kind of modifying it for my own good, and getting used to that, and learning about how to current regulate laser diodes, which saved a lot of laser diodes. 2.6 volts, 2.9, 3.4, 3.5, reading the voltage. That's a lot of fun. I really do love the technologies more than anything else. Right, well, we are up to 4.5 volts, and we are seeing no light output. So, I'll flip around the wires and see what happens. Of course, every time making sure that the power supply is reset to the low voltage and current that I want to start off with, thus not freshly cooking the laser diodes. Once more with opposite polarity. Yeah, just my general curiosity led to me building more and bigger laser devices and LED devices, and it kind of got out of hand at one point because I started to service other people's lasers and really enjoyed doing that much more than actually doing the laser shows. The actual technology involved with the laser stuff. Yeah, a little bit of red, I see it. So yellow is negative. Make note of that. Come on, will we laze? 6.2 volts, 3 volts per diode. No lasing. They are toast. Heavily toast. Well, that makes life more interesting, though, doesn't it? So it does seem that those are each 170 milliwatts. Probably the low power single mode laser diodes, and they are toast. This complicates things. For one, it complicates things because the particular laser diodes that I have to go inside as a replacement, as I said, are the 500 milliwatt Mitsubishi, the open can laser diodes, and the problem is the case is negative, whereas on these ones the case is nothing. They got the 2 pins and it's case isolated electrical connections. So in order to properly put in new laser diodes, I would have to get the proper laser diodes, and it looks like that they are installed by extracting the lens carrier assembly. It's probably a little subcarrier that goes in, pushes the laser diode in from the front, and then the lens slides in there. Kind of show you what I mean by taking off the polarized beam splitting cube. Yeah, the ventures of the DPSS laser technologies and the sudden progression of the blue and now green laser diodes have just made the laser show technology so much more affordable and so much more widespread than it previously was, which is incredible because the technology just keeps evolving, and that's what I love the most. So I can't really bring that up, and we'll look at that, and you can see right here what I mean by that little screw-in area. So the laser diode is held in by the outside carrier, and that lens piece goes on the front. Well, now there's a way that we could fix this, but those lenses really do look like they are designed for the very low powered, very thin red lasers, and I don't know if they'll be compatible with the 400 to 500 milliwatt Mitsubishi, especially with them not being case isolated. So I'm kind of considering just closing this back up and looking for those lower power case isolated laser diodes and just dropping them in as normal, or seeing if the other ones are also case isolated. So what I would have to do at this point is to see if there are any other electrical connections on this plate. Now it's going to be isolated from the laser base down here, but that doesn't mean that any of the other laser diodes or anything else might be connected to this whole but brass area. So I'm going to go ahead and test out the electrical connections between the laser driver here, so all of these pins, and then this brass base. If all of those connections seem to be open loop, I just might be able to get away with putting one of those higher powered laser diodes in there, but only one of them, since as I said, not case isolated laser diodes, and without access to remove this because of those screws, my options are limited. Yeah, knock over the optics. That's great. Alright. Continuity. So hopefully we'll read open loop on all of that. As you see here, the problem is that these are both joined, so we got fully closed continuity between those two. And of course then you get a negative pole here, and if you run it in series, it's just going to cut one of those laser diodes right out of the loop, because they're going to be connected with the two negatives. So let's go ahead and test. So one on the base and one over here. We're going to test each individual pin. Low. Probably going to be easier just to pull that. Alright, here we go. Low. Up. Alright, well, having checked all of those all of these driver pins in reference to the brass block, we just might be able to put one of the Mitsubishis in there after all. Go ahead and try that. One of the things about laser technologies to try to learn is once you're dealing with the raw components, such as the laser diodes and drivers and stuff like that, the price of doing laser repairs and stuff like that, even making your own laser doodads really isn't that expensive. It's when you get the pre-made equipment that it's terrible. So doing stuff locally, as far as like the laser shows and stuff like that, as I said, just wasn't enough. Repairing other people's equipment and stuff like that, lots of fun. And as I said, it did spiral. And so doing my own light up stuff gave me a little bit more of a recognition in the community, because not only was I a lighting tech and doing light shows, but I also made a lot of my own equipment, and that gave a lot of uniqueness to what I was doing and what I was known for. Where's the lens, Dave? Oh, the lens is still in there. Okay, well, not expected, but I can hang with that. Let's see what we get behind door number 2. So, after getting some notoriety for building my own stuff, I started building stuff for other people too, and eventually I started to work with somebody named Kurt, who did props for other artists and stuff, and he and I worked together on a few projects. Okay, there's indeed a lens somewhere. There's supposed to be a lens somewhere. I'm not losing my marbles. Where's the lens? Ah, that's held in there by another little claw thread. Dang it. I need to make a tool, or find a security bit to go in there. Holy crap, they don't want people in there, do they? Oh. That might work. That's still very odd that I don't see any kind of lens. Did it fall? Yeah. Found it. Come on. Do your job. That's gonna need some modifying. My modification is complete. Let's try this again. Oh, yeah. That does the job. And speaking of doing the job, that's something that I did. As I said, started to do specialty LED work for different artists and stuff like that with Kurt, as well as just doing general laser repair work and stuff like that I do now. Serviced many artists, including, let's see, Ghastly, Adventure Club, White Panda, Marshmallow, Atlians, Amped Up, one of those. Lots of them. We've done lots of specialty things for different people, and that's a lot of fun. My biggest goal in life is really to be pushed, have my skills pushed. I love learning and love developing skills. Yummy. Well, shall we try to put in a single Mitsubishi? I think we shall. We'll just leave the other one there for looks, right? Yummy looks. Alright. And I've tested these things all the way up to 0.5 amps, so it should be something that we can set the current for. Set the current for. Get in there, you little heathen. Well, that looks like an assembly I don't want to work on. Open can laser diode and all. But as I said, I like a challenge. So yeah, this is how I got into show lasers and stuff. Basically, just practicing and looking up information and learning about it. Mostly out of necessity. Lots of necessity. But I wouldn't want to do anything else with my life other than tinker around with laser bits. In some ways, I kind of feel like I feel very lucky
almost too lucky to know what I want to do in life.
A lot of people don't really know what they want to do, and I'm just like, ever since I was a little kid, I want to play with the lasers.
Lasers, gotta have lasers, more lasers. Can't have enough.
I have lost count of the amount of lasers that I have.
And there's still a whole lot more that I have to learn. As I said, in growing up and learning about this, there have been several levels of progression, and there will be more levels of progression. The OPSL laser market is the next one that I'm really looking forward to getting into, because the OPSL lasers in general, I think, are about to become a lot more available. The coherent patents, I think, are coming up on expiring, so because of that, then
anybody can make the OPSL lasers, and that means more colors for everyone.
more complicated lasers for me to fix. I like that. I don't like this little lens assembly though. Really. It is really the worst. Yeah, who designed that?
Yuck.
It's still not where I want it. That laser diode is still loose, but how are you still loose? I see. Must have went off at an angle putting it in. Cooperate. Whoever thought that this was a good way to mount in a laser diode didn't have the most fantastic of idea days, did they?
This is one of those
Consumer item saving measures, isn't it? Is there actually anything in that little hole? Sure as heck don't look like it.
bro. Right. Now let's see what happens when we hook power up to it. If it lasers, well, at least we have something. Alright, so positive was negative. Negative is case ground. Joy. And positive is now with my dummy laser test. I just need to know. Well, we'll get to it. Whatever. Negative first.
distracted at my work right now. Anyway, there's a lot of mystique about running laser diodes and stuff, and the current and voltage and stuff like that. And now part of what I want to do, just on the online platform like YouTube, is to take away a lot of the mystique with working with lasers. So more content to be posted up on my channel as I learn. And definitely, as I said, there's a lot for me to learn. Laser technology is an expanding field, one that keeps up with my curiosity and interest to know more. Where did I put that blasted laser diode I had for testing that has all the markings and stuff on it that I need to know for wiring it? I just need to know what positive is. Alright, positive input is on the right. So, as I said, laser diodes are set with current, not voltage, so it looks like the current setting on this laser driver is only the 0.15 amps. For the two laser diodes are about 150 milliamps, which is not enough power to fully run this Mitsubishi diode, but I just want to make sure that it is indeed able to be run like that, especially because this whole base right here is going to be the ground plane for that laser diode. I don't know if it's going to work or not, so I'm going to find out. I do know one thing though, and that is that it looks like this is isolated from all the other laser diodes, so we should be able to get away with it. Crossing fingers. Alright. Right. With that on, a green connection in, move that wire over. Cool. ILDA plugged in. Laser program on. Green selected as our input signal for the red at this point. I don't have to worry about size because no galvos are connected up to it. Right. I have to plug in the laser head. Something we have to adjust the laser driver power because, as I said, I believe that it's going to be set too low to run that laser diode fully. Right now we're just looking for issues. So we got the laser driver here. Hopefully that won't be a problem. I can plug it in. Shall we plug it in? We should plug it in. Anything we break, we can fix at this point. Plug it in. No problem so far. That's good. But do we get a red output? No, we do not. No, we did not enable laser. Well that helps. Gotta have some kind of output to have output. Tries again. We have output. Output good, output bright. How bright is outputs? Oh. Weird. Well, let's check the current going through there. The current should not be exceeding 0.5 amps. It looks like it might be. So, on the upside, the laser diode does work. On the downside, a laser diode doesn't quite work. But we're learning. Isn't learning fun? Unplug. I wonder why the output's dipping down. If it's going above that that 0.5 amp range, 500 milliamp range, right now, then that means that we're actually overpowering the diode and it's going past the lasing potential. And at that point, it kind of gets a little weird with reds, because not always do you cook them, but sometimes if you push them right off the bat,
they'll drop out of the proper configuration. They kind of get lossy and start emitting dirty light instead. See what we get. It shouldn't be dimming down. Current. Check the current. All right. Plug it in again. It is plugged in again. Brightness. Point 5. 0.6. What happened to our output? Aww. Well, that's very interesting. What did happen? Oh, it's back. At 0.2 amps. Still not enough. Well, at least it seems to be working. So, I'm gonna see if I can collimate it. See what we get. Okay, as you see, I have a collimated beam now coming off the red laser. So now we get to mess with the current settings. For the time being, I'm going to unplug it and situate the camera. I have the meter already still hooked up to it. So now we get to say let's not cool this down to the point where this condensates water. Well, figuring out which potentiometer is the current adjustment. This is going to be an interesting and quick game. So let's see. First we got a static image. That way we get the smoothest measurement on the meter. And we play the delicate game. Alright, so shows nothing right now. We got the two potentiometers to mess with on the laser driver. Sure, one is for voltage and or gain, and the other one is for current. So between this and these right here, these two potentiometers, we're going to be figuring out what is what. So back over here to the output here and the laser, and we're going to see what gets us to about 0.5 amps. I believe we have about 0.45 amps, so that way I know that I'm not going to cook that Mitsubishi diode, and I've tested it all the way up to half of an amp. So I'm going to look for that 0.45 number, and we're going to continue. As I said, I can't run the laser head continuously because it wants to suck the moisture out of the air. So I don't want that getting damp. Let's begin. And while we begin, talk a little bit more about what I want to do in the future now. As I said, what I want to do in the future is just explore new laser technologies and just learn more about them as much as I can, and share that same type of technology with everybody else. So already 1.3, that doesn't seem to be right. You should be getting a lot more than that. Anyway, let's continue. See which does what. But yeah, I definitely want to learn more about laser technology. Certainly so. Well, that doesn't seem to do anything. Let's try the other potentiometer. Okay. Oh, that helps. Well, now we're on DC. 0.3, 0.32, 0.33, 0.34, got it. And 0.45. Cool. We're gonna unplug it, see how it looks with the other colors. Let all the moisture get out of there. As you can see, still some condensation on there. That's how fast that laser cools down on the inside. I am not joking. Seriously, do not have your laser head cool down that quickly. It makes for open laser surgery very difficult. Very difficult. So, looks like that's good. Well, this kind of dries out a little bit. Yeah, that was quick. I'm going to also remove some of the extra wires and stuff hanging around from the other laser diode that's no longer connected to anything. Kind of keep that open. And we'll keep that polarized beam splitting cube out of there because I don't think we're going to need it. So yeah, my goal right now is to learn more, mostly about the OPSL lasers and a more complicated DPSS lasers too. They're very similar technology, both the solid state lasers that are either pumped through crystals or through special semiconductor chips that have all these special little parts and stuff on them. The Briggs mirror and all the other goofy stuff that takes one form of IR and turns it into another form of IR, which I still need to learn more about. That's okay. I'm getting fairly good with vanadium lasers. So, learning. Also want to learn more about gas lasers. Would definitely like to get some different color helium neon lasers and stuff as well. I've got an argon ion. I need to build a power supply for it. Those are definitely a little bit more scary than these. Yeah. At this point, I think we can throw some heat shrinks on everything as well. So, there's definitely a lot of things that I want to do. I feel like I'm at a learning cusp of a whole new frontier. I can't be stopped, and there's so much to do. So much to do. Alright, so what I'm going to do now is just kind of heat shrink those ends. I took the meter out of the loop, and now that I have my set current, we should be good. It's a little bit much heat shrink for that. I can cut that down. And I'll save that other piece for the other side of the laser diode that's on the negative. Focus. I swear you can get a better focus. I was right. Using that gut feeling. Get that out of here. I do always encourage people to try to get into what they want to do. Even if it's plumbing. That's a great example of plumbing. You think plumbing is a simple thing, but then you look up something like the plumbing inside of a computer data center, then that's a lot of plumbing for all the cooling in the building. Anything that people can think of can be taken to some really crazy extremes. Lasers are just one thing that can be taken to really crazy extremes. And those are the extremes that I hope to get into and bring
on this channel. Rolling big time. For as long as I'm doing, I'm not failing.
And even if it's not done exactly right, it still works. And that is the important part. Right. Another little bit of a heat shrink between that wire and the positive input. And we'll be good just to heat shrink everything. Put the case back on, get it mounted into the laser again, and check and see what the white balance looks like. But it should be fairly close, especially if I'm running that Mitsubishi at about 400 milliwatts, and it's only supposed to be a 340 milliwatt output from that laser head. It should be pretty darn white. I will definitely say, looking back at what I do now, it's nothing that I could have really imagined back when I was in like high school. There's so much life out there to live for anyone, and that's the beautiful part about life. Alright, I'm gonna go ahead and heat shrink those up together, and it'll also dry out any of the moisture out from the laser head because of the heat, and we'll be good to close up. Okay, so what I'm going to do now at this point, now that it's all prepared and ready and set, is I'm going to go ahead and reassemble this, put this back in the laser, and see what our color balance is with that new laser diode put in. Hopefully it looks good. The laser head is now put back into the laser, and it's time to turn it on and see what happens when we have modulation coming in from the ILDA signal. So, first step, contact on. No smoke, things moving. Laser light coming on. We'll get just figure the colors right now. The red needs to be aligned, but that's to be expected. Let's get some other things going on in there, and we'll move the red to the appropriate place of alignment. It looks a little low. Yeah, so move that. First order of business. Where did the red go? Did the red just... Ah, crikes, don't tell me that that red just cooked. Of course it did. Aha. Right, well, that's not good. As you saw in the previous video clip, the installation of the new red laser didn't go quite well, as the laser diode decided it was going to burn out. Tried this a few more times, and it just resulted in 3 more bad laser diodes. 3 of them suffering from catastrophic optical damage, and 1 of them just blowing the gold bond wire right off the top of the laser die. These were in slightly different circumstances. So originally what I thought was happening was that there was condensation getting on the quantum well of the laser diode and causing a short or something like that. So I tried it again, and I made sure that the case did not cool it down enough to get the water to condensate on the laser assembly, which is fine. Cool. I got it all put back together again. Laser diode died. Went back and retested the current, same current. It was the 450 milliamps that I put in there before, which should have been suitable, and it should have absolutely been suitable. But I decided to drop it down to 300 milliamps on the third one, and still no go, which is weird because the one that I originally connected up to 500 milliamps on this laser driver is working just fine, and has worked just fine for several hours with absolutely no problem whatsoever. The laser that I put in last, I set down even lower. I set down to that 300 milliamp range, 0.3 amp range, and I also turned it down after getting it focused and set in. Same thing happened. I wasn't even touching it, didn't look at it funny, had all my blessing inside of it, and it still decided it was going to fry. So I'm definitely thinking that there is some kind of problem with the driver, whether it's a bad comparator or a bad potentiometer resistor somewhere in the little network here. I'm not quite sure. So what I can do with this one in the future videos, because there will obviously be more videos, is to get better isolated laser diodes for this, and to either try to fix whatever is problem with the laser driver here, or just get a analog laser driver off like eBay or whatnot. They're pretty cheap. They're about $8 to $15 depending on the driver you get. So, and I've had some good luck with some of them. But as my aunt said, that's life, kiddo. And that's why my one rule is that nothing can be easy, because it rarely is. And if you can't live with that, well, you're not made for greatness, because greatness requires lots of failures. Speaking of great things with lots of failures, good news. If you're enjoying this video series, a fourth Cittadini laser has shown up for repair. This one having problems with the green laser's modulation where it will not shut off, and a laser driver that has a modulation issue is a lot easier to work with than a laser driver that has a power issue. So, I'll be getting in there. This laser also requires a new key lock in the back, which will be installed as well. So, this video series is now officially the repair of 7 show lasers. That's right, 7. That's a lucky number. Well, I hope you enjoyed this video, and as I continue on learning more about the different laser technologies, I will also continue posting up more videos, so that way everybody else can learn with me on my adventure to see all of the light. That's all for this video. I hope you enjoyed, and as always, stay tuned for more. You know what's coming.